We want to write these problems so that no negative exponents appear, only positive exponents. So in 14, we're going to do this. We're going to use this rule where we can move a base up and down if we just change the sign of the exponent. So we're going to move the m up and change the exponent to a positive 3. So we're going to get 10m to the positive 3. In 15, we've got a negative exponent here, but we can eliminate it. We can make it positive if we drop the base into the denominator. Right now it's in the top. Move it to the bottom. So we can write this as y to the 4 over, now drop the x down, x but to the positive 3. Number 16, a couple ways to do this. You know what? I'm going to write this one over here. Here's 16. We have x to the 5 over x to the negative 5. Now one way to do this would be just to bring this x up and change the sign of the exponent. So if I did that, I would get x to the 5th, and then bringing this x up, bring that x up, we'll change that negative 5 to a positive 5. And then we've got a multiplication, so we add the exponents, so we'll get x to the 10. Now another way of doing this is use the quotient rule, which says to write the base, take the top exponent minus the bottom exponent. Be careful with all those negatives. Got it? Top minus bottom. So top minus bottom. And that will give us x to the 5 plus 5, which still gives us x to the 10. Now number 17. Let's write it. It's r to the negative 6 s squared over r to the negative 8 s to the negative 5. Now again, we have a couple ways to do this. We could, if we wanted to, bring this r down and that r up and that s up, right? Get rid of all the negative exponents. Change these bases, their positions. That r comes down, this r goes up, and then this s goes up. Or we could just directly use the quotient rule. Let's just try the quotient rule here. So I'm going to get r, and now the top exponent minus the bottom exponent. I'll get s to the top exponent minus the bottom exponent. This will give us r to the negative 6 plus 8, s to the 2 plus 5. So this will give us r to the, now negative 6 plus 8 is 2, s to the 2 plus 5 is 7. And in number 18, well, there's a couple ways to do this one too. You know, I'll write it down here. 18 is this one. It's the quantity x plus 4 to the negative 3. And as I write that, I remember that anything in a parentheses is just considered as one thing. So this is just one thing with a longer name. It just as maybe, well, it be an a to the negative 3, right? Maybe give it a nickname, a to the negative 3. And in the bottom, we've got the same base, x plus 4, but now to the negative 4. So we could use the quotient rule. You know, you could do this. You write that base in top exponent minus the bottom exponent. Gives you x plus 4 to the negative 3 plus 4. Gives you x plus 4 to the 1. Or how about just, we don't need those parentheses now. So we can get rid of those parentheses and just write x plus 4. Or what we could do is we could bring this base up and this base down, change the sign of the exponents. It's going to look like this then. That top x plus 4 will come down, x plus 4, but now to the positive 3, right? You can move things around, up and down, if you change the sign of the exponent. So I'm moving this one down, but I have to change the sign of the exponent. Now this one here is going to go up, but I need to change the sign of that exponent. So it's x plus 4, x plus 3 to the 4th. And now I've got a division here, so I'll write the x plus 3. No, why am I keep saying 3? What's in there? That's not a 3, it's a 4, right? Got too many 3's and 4's here. So it's going to be x plus 4 now to the 4 minus 3, or just x plus 4. Either way I do it, I get the same result.